First of all, I would like to thank our honorable speaker, Mr. SOUMYAJIT, to give us this opportunity and all our friends, those who have attended this PPT. I am very glad to see you all.
Thank you.
Today, I am going to, I and my teammates, PRALAY MUDY, SHRESTHANSU CHATTERJEE, and myself, SAGNIK GHOSE, going to present this PPT on impact of solar energy and environment pollution. So in this presentation, we are going to cover introduction of solar energy, what is solar energy and what is solar energy potential. Second thing, solar energy availability. Next, types of PV cells, how many types of PV cells are there and what are their functions and what are their work. Fourth one, how solar panel work, mechanism of solar panels. And fifth one is impact of solar energy in our daily life, is day-to-day life, what solar energy is useful. And second and sixth number is advantage and disadvantage of solar system. Seventh is conclusion and eighth is acknowledgement. We are going to start our PPT. First of all, what is solar energy? Solar energy is radiant light and heat from the sun that is harnessed using a range of technologies such as solar power to generate electricity, solar thermal energy, including solar water heating and solar architecture. It is not possible for life on Earth to exist without solar energy. All kinds of microorganisms and single cell organisms came into existence with solar energy's help using photovoltaic cells, and we can produce electricity using sunlight. Potential of solar energy. In addition to being free as an energy source, it does not cost money to harness it, and it turns into electricity. Energy from the sun is practically limitless. The surface of the earth receives solar energy at an average of 343 watt per meter square. If we multiply this times the surface of the earth about 5 into 1014 meter square, we get 1750 into 1014 watt. 30% of this is reflected and only 30% of the earth is above sea level. So the usable solar energy we receive on the land is about 360 into 1040 watt. We need to reduce this because not all of the land surface is suited to installation of solar PV cells. We do not want to cut down forests and ice covered area are not suitable. So we reduce the area above one half. Over the course of a year, this amount of solar energy adds up to 66 into 1022 joules. In 2018, we used about 600 into 1018 joules of energy, which is just a shade less than 1% of the harvestable solar energy we receive on the land. Next, it is the global average solar radiance. Area in red have a higher strength than solar energy resources on average. The black dots indicates the area sufficient solar energy. So the black dot indicates the area with sufficient solar energy potential to supply the world entire energy demand. As you can see that the black dots are present in America, South American continent, African continent, Middle East and Asia. These are the areas where the maximum number of solar potential is there, which can fulfill the world demands. So the annual solar energy potential by region wise, we can see the minimum potential of North America is 181.1, Latin America and Caribbean 112.6, Western Europe 25.1, Central and Eastern Europe 4.5, former Soviet Union. It's now currently it's divided into many countries. It's 199.3, Middle East and North Africa it's 412.4, Sub-Saharan Africa which is 371.9, Pacific Asia 4.1, South Asia 38.8, Central Land Asia 115.5, and the maximum solar potential of North America is 7,410, Latin America and Caribbean is 3,385, Western Europe is 940, Central and Eastern Europe is 154, former Soviet Union, which is now currently divided in many countries, as I said earlier, it's 8,655. Middle East and North Africa, it's 11,060. Sub-Saharan Africa, 9,528. Pacific Asia, 994. Southeast Asia, 1,339. Central and Asia is 4,135. This is the another photo diagram that the power of photovoltaic cells are there. As you can see, the red area where the maximum number of solar potential is there, which can fulfill the world's demand, and there is yellow buttons also there, which are the amount of solar potential which can fulfill their domestic needs. So I am proceeding further. Then what solar photovoltaics then? So what is solar photovoltaics? When most people think of solar power, they think about one of the things vast array of solar collectors laid out in hot deserts or smaller array on rooftops or highways. This is perhaps the most common methods of converting solar energy into electricity. But it is not only the method, but arrays of solar collectors are also known as solar photovoltaics. As you can see in the diagram, it is only set in the rooftop or in the plain area where the maximum sunlight can be utilized. Then what is PV cells or photovoltaic cells? The photovoltaic cell is an energy harvesting technology that converts solar energy into useful electricity through a process called photovoltaic effect. There are several different types of PV cells which all use semiconductors to interact with incoming photons from the sun in order to generate an electric current. There is various solar cells photo, as you can see in the diagram. So now I am calling my teammates, Mr. PRALAY, MUDY, to take over the duty and going further.
Good afternoon, sir. Good afternoon, everybody. Now my part starts with the types of photovoltaic cell. So we can subdivide the photovoltaic cell into three divisions. One is silicon based, another one is non-silicon based film, and there are some new concepts which are developed in nowadays. So silicon based are divided into two subdivisions: the crystalline silicon and amorphous silicon thin film. And now the crystalline silicon also divided into three parts. And the non-silicon based thin film photovoltaic cells also divided into two parts. So now, based on their internal structure and their efficiency, there are four types of photovoltaic cells. One is concentrated PV cell, whose efficiency rate and performance is very high, but it needs solar tracker and cooling system. Another one is monocrystalline solar panels, which also efficiency has very high and also they are very durable, but their cost is very high. And now the thin film amorphous silicon solar panels, their efficiency is also good. Their cost is low, but their lifespan is very short. And the last one is polycrystalline solar panels. They are less expensive, and they are under developing their efficiencies, and they are not durable as the previous ones. Now, the structure of a photovoltaic cell. So, a photovoltaic cell is comprised of many layers of materials, each with a specified purpose. The most important layer of a photovoltaic cell is the specially treated semiconductor layer. It is comprised of two distinct layers and is what actually converts the sun's energy into useful electricity through a process called photovoltaic effect. On either side of the semiconductor is a layer of conducting material which collects the electricity produced. The final layer, which is applied only to the illuminated side of the cell, is to anti-reflective coating. Now, the science of making of PV cell. So, the making of PV cell starting with from the sand. So, as first we product the main thing which required to produce PV cell is the silicon. So for making of PV cell, you take the help of most abundant element on earth, that is sand. So the sand has to be converted into 99.99% pure silicon crystal to use in solar cells. So this is for this we have to go through a complex purification process. This process shown there. So from this we get 98% pure silicon, but this is not usable in the photovoltaic cell. So further we go through a process. We convert the raw silicon into gaseous silicon and then mixed up with a hydrogen gas to get highly purified polycrystalline silicon. So there are the silicon structure. So if we see the basic silicon structure, we can see that there are the silicon atoms are bounded together. So there are no free electron to move or conduct electricity. So we have to add some free electron in the silicon structure. So we have to, for this, we have to dope some elements. So we add phosphorus to make it a n-type semiconductor. So as phosphorus has 5 valence electron in its outer cell, so if we dope phosphorus in pure silicon, there will be a extra electron present in the silicon phosphorus structure. So when the free electron gets sufficient energy, it will flow through the semiconductor. But the flow of the electron is not is random. But we need to unidirectional flow of electron. So if we connect load around this semiconductor, we do not get any current. So for solving this problem, solve this problem. There is a simple solution to make a p-n junction. So as the n-type is made, if we dope in the pure silicon group 3 element like boron, then there will be hole present in the boron silicon joining structure. So if we merge them, the p-type semiconductor and n-type semiconductor, then there will be formed a depletion region. As the n-type, there are electrons, and in the p-type region there are holes. So some electrons from p side comes, some electrons from n side merge with the holes of the n side and create a depletion region. So now the upper side of the depletion region is slightly positive and the lower side of the depletion region slightly negative. So there will be create an electric field. So now if we when the light strike on the electron of strike the depletion region of this semiconductor, there will it breaks the electron and holes bond and create a pair of electrons and holes, which for the electric field produced in depleted region, the holes will move to the p side and the electron holes will be moved to the p side, and then if we connect a load around the semiconductor material, then the light will glow and will conduct electricity. So now comes to the practical PV cell. So in practical PV cell, the upper portion, the N side is heavily doped and the P side is thick and lightly doped, so that the depletion region and thickness is going to be very high. So for this purpose, when the light strikes the inside of the region, it comes to the depression region very fast, and more electrons and host pair will be generated in this region. So current will be generated very much. So now a single PV cell produce only 0.5 volt. So if we so one PV cell not sufficient to light up a single bulb, so we have to make a combination of series and parallel connection of the cells to increase the current and voltage to a usable range. Now there are the solar PV cell efficiency. There are many the hydroelectric power, tidal power. Their efficiency is very high, but as compared to solar photovoltaic, so we are making some innovation to make the efficiency high for now. So now the comes to the impact of solar energy in our daily life. So this one will be introduced by system.
Good afternoon, sir. Good afternoon, everyone. So my part is starting from impact of solar system in our life. Solar system is renewable, inexhaustible, and affordable form of energy. There exist two types of solar devices. As one is active device, and number two is passive device. Using solar system, environmental pollution can be reduced to some extent. One of the cleanest and purest forms of energy. Some of the applications are heating, indoor and outdoor, or lights, transportation, etc. Uh, Below some of other uses: solar energy for cooking, solar energy for houses, solar water heater, solar energy for battery charging. So first we will discuss about solar energy for cooking. Using solar energy for cooking is very simple. Every day we use fuels for our cooking, and we can save from using of solar energy in cooking. Instead of cooking in a conventional oven, cooking in a solar oven will surprise you with the electricity bill. To cook in a solar box, you recommend thermometer, a box with aluminum foil, conduct tape, cooking bag, and styrofoam insulation. Number two is burning fuels such as wood and gas for cooking. Where burning and polluted area, the pollution will reduce from using of solar energy in cooking. Say some types of solar cooker, box cooker, solar panel cooker, simple solar box oven, parabolic cooker, etc. etc. Now I'm coming to home appliances. Installations of solar panels in the home premises is gaining popularity because this is save money. This is because solar panels generate electricity from an inexhaustible source from sun. The energy generated can be used to power home appliances such as TVs, fans, computers, even heavily machinery. So solar installations can be expensive for the first time, but after that the money will save. The next point is water heating. So solar hot systems use sunlight to heat the water in middle geographical latitudes between 40 degree to 40 north to 40 degree south. The cold countries, 60 to 70% of the domestic hot water use with water temperatures up to 60 degrees centigrade, 140 degree in Fahrenheit, can be provided by solar heating system. Most common types of solar water heaters are evacuated tube collectors 44% and glass flat plate collection 34% generally used for domestic hot water, and unglazed plastic collectors used mainly to heat swimming pools. The next point is solar distillation system. What is solar distillation system? It is a process in which the energy of sun is directly used to evaporate fresh water from sea or some water source. Solar distribute can be used to make saline or brackish water potable. The first recorded instance of this by 16th century out of alchemists. A large-scale solar distillation project was first constructed in 1872 in Chilean mining town of Las Salinas. Next point is solar energy for industries. We know in industries electricity at high level, so we can save electricity like while other instruments by using solar energy to use the heavy machinery and equipment. The power supply can be given through solar energy. Using solar energy will keep the electricity bills in control. Next one is very important in agriculture. In India and other countries, lots of places are not eligible for electric supply. Solar water pumps are lifesavers. Solar pumps use solar energy. We can use solar energy in solar pumps and in many agricultural instruments like harvester, etc. And panels to pumps which would save hours of time for farmers. Here, solar panels are employed to harness the solar energy and using inverters. DC power is supplied to the power grid or stored in batteries. This power will be used efficiently to run the pumps to supply the water. Next one is remote supply electricity. Here, farms might be located in remote areas where the electricity supply is limited and farmers may constantly face issues related to power outages and shortages for running their equipment and tools on the farms. Solar PV systems are employed in the farms to produce the requirement electricity that is stored in batteries and used when required. This is not only just in reducing the power consumption from the electricity supply, but also saves money for farmers in the long run. Next is solar transport. We every day we use many vehicles for our transport. We also can use solar system in our transport vehicles like toto, trains, boats, ships, etc. It will also save our money and electricity. Some advantages of solar energy. The first one, reduce cost of our energy bill, and second is renewable energy source. The third point is wide range of solar products, low maintenance cost. However, can become energy independent. Power can be stored and used at night. Solar panels have long lasting warranties. This is the very important. Solar panels have long lasting warranties. Solar panel technologies is becoming more advanced. And ninth point is cost of solar panel are becoming more affordable year and year. Some and then options to change your electric vehicles from your solar panel system. And the last point is solar energy was announced the cheapest form of electricity in history. So I would like to continue the rest of the to Shagnik.
Okay, so then the next slide is pollution due to solar energy. As we all know that solar energy is a renewable energy and it does not cause any pollution. But the dark reality is that in our world there is no such energy which do not pollute the environment. So if we look at the one of the most popular renewable energy, solar energy, that solar power is imperfect. Like everything in life, there are some ups and downs. There are some of the examples or downsides of pollution due to solar power. First one is energy demand. Demand. As we can see that the solar energy requires a significant amount of energy from producing, mining, manufacturing, transportation, all require solar energy. What must be processed and cleaned and then manufactured with other components which may be from different facilities. Manufacturing requires multiple materials which incredible precision of high efficiency panels. All these requires a lot of front energy. With traditional fuels such as gas or coal, they are extracted and cleaned or burnt at very large scales, typically in a single location. Number two, chemicals. To produce solar grade silicon semiconductors, processing typically involves hazardous chemical. Depending upon on the solar manufacturer and country of origin, these chemicals may or may not be disposable properly. Like every industry, these companies leading by example and other which cut comes corners to save cash. Not every company will dump chemical or won't recycle their byproduct properly, but there are bad appliances out there. Then the recycling. What happens when solar panels are become efficient? Although solar panel recycling has not becoming a major issue yet, but it will in the coming decades as solar panel need to be replaced. Currently, solar modules can be disposed of with other standard e-waste. Countries without robust e-waste disposal means are at higher risk of recycling related issues. So the disadvantages of solar energy is so the disadvantages of solar energy, it is very much costly. The size of the system is dependent on the available size wherever you set this system. This requires sunny weather to work best. Manufacturer of solar panel can harm the environment. Solar energy conversion rate is very low. Whatever the energy solar panel takes, it only produce 30% of that. It cannot be used at night. Your energy could get waste on export limit, means whatever the limit it is getting higher, then it will be waste, become waste. So the conclusion of the whole PPT is that solar power is an immense source of energy, directly usable energy, and it is also plays a crucial role in modern societies. It has a vital input to all the sectors and is essential to generate electricity. By using such types of energies to generate an environment can be protected from global warming. Solar energy right now is minimal and does not make enough difference to justify the cost. And in future it probably have the greatest amount of potential because it does not have to be manually pursued. So at the end, thank you.